Hiya, my name's Luke, and today we're going to talk about insulation, particularly fiberglass insulation. It is currently about -6 in Manitoba right now. It's December, which is actually kind of warm for a day in Manitoba in December. Anyway, most people are familiar with this stuff here. Can you see that there? The pink fiberglass insulation. But we also use a lot of this brown stuff here. I'm assuming that Owens Corning, the guy that makes this stuff primarily, just they put in the pink dye into their stuff to make it look more friendly, and other people simply don't. So anyway, this is fiberglass. Fiberglass, of course, is made out of sand. That's right. Sand melted down into glass and then spun into fibers like this, much the same way that a cotton candy machine spins it. They actually blow air into it while it's swirling around, and it comes out, and they make it into this form. This piece was cut down, so it's a little small, but this is an R20 bat. That's the thickness there. It gets to close to 6 inches. R20 is the value of insulation, the value of heat resistance that it has. I'm not going to go into the details of that because I don't remember the details that I learned about that in college. But this is how it basically works. You have got, actually I'll hold it up by putting it in the wall here.
Wah! My insulation's falling down! No!
Okay, stay up, insulation. All right, so we've got our insulation in the wall here. And let's say this is the inside. We got our heaters here on the floor. And let's say that we're heating this up, and this whole space is just all these studs are all filled with insulation. This whole space is insulated, and there's a door here keeping this a conditioned space. This air in here is going to feel different than air over here. All right, of course, you get that. All right, now this warm air on this side is going to be able to hold a lot more moisture. Please understand this. Warm air holds humidity. Cold air does not. The colder the air gets, the less humidity it can hold on to. What happens to that humidity? It falls out. The water drops out of the air and condenses on surfaces. Cold surfaces first. And so the humidity goes from being a water vapor, where it's traveling through the air as vapor water, and it transforms into a solid. That's what happens. The air cannot hold on to it. It transforms into a solid. It condenses. So, okay, back to the illustration. We have got warm air in here. Nice warm air. It gets humid because warm air can hold more humidity, and water sources to create that humidity are all over the place, including me. Showers. Cooking in your kitchen, pets, the materials in your house will still be drying out in a new house, and they can actually retain moisture and let it go throughout the year. There is sources of humidity, I'm telling you. All right, stop me if this gets a name. Anyway, this humidity in here is gonna be inside that space, and as the heat is transferring through our insulated wall, it slows down. The heat transfer slows down. If there were no insulation in there, the heat would just fly out, and it would just transfer through whatever barrier we had here. And if it was not an non-insulated barrier, it would just basically transfer through, and the humidity would dry up so much because there's so much air moving on this side and this side, but the air moves slower through the insulation. And the heat moves slower through the insulation. The heat, let's say that it's +20 on this side, and it's -20 on this side, or -6, whatever, it doesn't matter. It's below freezing. It's cold on this side. In the middle of that piece of insulation, it's probably going to be, well, okay, let's say if it's +20 and -20 in the middle of the insulation, let's just guess that it's going to be about 2 degrees in the middle. Let's say it's about that. And so once it gets to 0 degrees, once it gets to the dew point inside of that wall, which is a term that I do not fully understand, but that's when the air is going to start losing its moisture, and you're going to notice the condensation because of the dew point. But I mean, we already get the idea that the warm air loses humidity when it gets cold. So that warm air is now down to 2 degrees, and then by the time it gets to this edge, it is now below freezing. And so all that warm air has dropped its moisture, and now this insulation is actually wet and frosty on this side. It gets wet, and we have moisture in our walls, and that's what insulation does. If somebody tries to tell you that having an airtight house is bad because you get moisture in your walls, they're wrong. It's actually the insulation. It's all its fault. Okay, back to what we're talking about here. Think of it like a filter. You got moisture air on one side, and it goes through that insulation, and it comes out dry. It's almost like your furnace filter, which happens to be made out of fiberglass, but and so it actually can be used like a filter in that way. But that's not actually what a furnace does with its fiberglass filter, so let's not get too far into that idea. But think of it like a filter. It filters out the moisture because it's slowing down the heat transfer. We want that heat transfer to be slow, obviously. Otherwise, our houses are just going to be cold all the time unless we have a big, gigantic, roaring fire burning like people used to. Or your furnace is just running constantly and you're paying $1,000 a month to try to heat your place, like I did one winter. Long story. Anyway, that's how insulation works. You can see how all the walls in this house have got insulation as well as plastic on everything. I'm going to make another video to talk about vapor barriers where I'll get into the plastic and the black caulking that you see. On the ceiling, however, look at that. There is some crazy, crazy frost developing on this ceiling. That is because they have not blown in the insulation into the attic yet. That's not terribly uncommon. Construction happens in different stages, and so we currently have an interesting stage where the walls are insulated, but not the ceiling, and we can see frost. Look at all that frost. That's because the plastic won't let the moist air go through, and there is no insulation there, and so it just gets instantly cold, and so that's why there's condensation on the ceiling, but not on the walls. That condensation, of course, is in the form of frost, and you can see it all. I can make a little smiley face in there and draw it on. Let's see if I can do that. Hold on. Okay, that's the start of the smiley. That's frost. All right. So hopefully I have taught something about insulation. I think that's pretty much all I want to go on in this video. I'm going to make another one about vapor barriers and then possibly more. All right, see you later.